Hello everybody, here we are, and let's simply get started from here on. The last time I was actually working on the design of, high level design of URL shortener, so we will continue from there on. And first of all, we will get this thing done, and after that we will start working on the deployment part. So let's see how many things we can actually cover right here, but it's going to be pretty much interesting. So let me get some configuration done. And lastly, turning it off will do the job. Am I audible? Done. Okay, ignore the background noise. The fan is running right now, so I cannot really do anything regarding that. And apart from this particular thing, everything else is fine. So how many things we covered? We covered these many things. First of all, we discussed exactly what we have to build. So we have to just simply build a URL shortener. After that, we just simply assumed some of the things that okay, there are gonna be 20 million writes per day, and the UI should be as short as possible. And then as for the characters, 62 characters are gonna be here, and we just simply got the back of the envelope calculation done, and then we got all these estimations and all. And lastly, we started talking about how we can kind of shard the DB, ultimately how we can horizontally scale the database. And for that thing, we are going to be using consistent DB. And what happens here actually, in the consistent DB, you have a hash ring over here, and hash ring is divided in numbers like between 0 and 100. And then the databases are just simply assigned to those points. Like there are specific points, and databases are assigned to those points. And like one is assigned to 100 here, another one is 25, then one is at 50, and then one is at 75, something like this. And not only this, then we have databases on those specific points. And apart from this particular thing, we have replication of the databases. So we have proper replicas. So suppose this is a DB4, so this is gonna be here as well as here. Why do we need a replica? So that whenever something is getting stored, that gets stored in all the databases. So if something gets stored in this particular replica, so that will be auto synced to this particular database. So this is how it's just simply gonna be going on. Again, verbally things are gonna be hard to understand, that is for sure. But if you actually pay a little bit, if you just try to know more about it, it's gonna be easy. Continuing from here, let's simply get the replicas of them. So ultimately here I'm working on the overall structure, how the things work and all. Even if you don't have them, that doesn't really matter. Like even if you don't create it, if you understand, that's more than enough. But in my case, I'm just simply busy creating them. So this is how I will have different replicas as well at different points of this hash ring. And once this whole sort of environment is created, this whole way of horizontally scaling the database horizontally is done, then whenever a user wants to just simply save something in the database, so this is gonna be kind of hash ring. And whenever a user wants to save something in the database, so that user will definitely have its own IP address or the user ID. It will definitely have something or the other. Suppose we are just simply dealing with the user ID. So once we get the user ID, then we will hash it by 100 or something. We will first of all convert in. We will pass this ID through via a hash function, and then hash function is just simply gonna be converting it to a number. And once we get this number, so we will be just simply once we have this particular number, we'll be hashing it by 100 or something if I'm not wrong, so that we get the numbers between 0 and 100. And once we get that, then on the basis of that thing, suppose if the number is actually 25 in that particular case, so if the number is this 25, so this is the kind of user ID is hashed number ultimately. Again, this depends on the hashing exactly which kind of algorithm it uses. But if at the end of the day we are going to be getting some numbers between 0 and 100, and if the number is 25, and suppose 25 is here, so it's going to be the data will be saved in this particular DB. And if sorry, that's 25, not really. If that's 25, so we already have a database at 25, so the data will be saved here in this particular one. If that is 26, then the data will actually be saved in this one. If that is suppose 55, so probably the data will be saved here. If that is 75, the data will be saved here, and see how the things are going to be going on. Alrighty, this was all about talking about the things verbally. I know it doesn't really make any difference, especially when you uh, hear me talking about them verbally, but okay, that's never mind. Ultimately, there is something called consistent hashing. Using that, we just simply horizontally scale the database, and this is how the things are gonna be done. Alrighty, so we have talked about this thing as well. And what is the next thing that we have to talk about? Let me just simply have a look. We even talked about the database, like which one is gonna be the best over here. We actually selected SQL, structured query language over here, and then we even talked about the algorithm that we will be using for horizontally scaling it. And once this particular thing is done, so let me see if there's anything missing. Just a minute. So we have talked about this, great, and consistent sharding, that's fine, consistent hashing, and so ultimately we will have to just hash the value over here. Hashing in the sense we will hash the user ID. So suppose when the user sends a request to just simply save some data, so we will be hashing the user ID, then that particular user ID will actually be converted to a number, and then we'll take the modulo or something, again whichever algorithm is used by that particular consistent hashing way. I mean, it will automatically be used if I'm not wrong, otherwise we'll do it manually. We'll just simply get the modulo by 100 or something, and then we'll be getting a number between 0 and 100, and that will be just simply forwarded to these databases as referenced here. And apart from this particular thing, this is one of the things. And the another thing is that when it comes to getting the there is one more thing. We have solved the problem of the database, like how the values are gonna be stored and all. Now if we get the, so first of all we are hashing over here, so we are hashing for the database, so that's gonna be like we are just simply using the hash function over here. Hashing, that's hashing is getting done for the database. Second hashing that needs to be done, so that will be using some algorithms, some sort of algorithms. They are actually, what are they called actually? There are some, they are algorithms, like we have SHA-1, we have SHA-256, so we have MD5 and all. So these are algorithms that are gonna be used. And then one more hashing that will be done for the long URL. So ultimately, whenever I get the URL from the client side, one more thing, as soon as I got the URL from the client side, I will be just simply saving it here. So suppose long URL actually got saved here. As soon as the long URL got saved here, I will get the ID over here. Suppose the ID is one this time. Once I got the ID, I'm actually gonna be hashing this ID to base 62, because there can be maximum 62 characters. So I'm gonna be hashing this ID to base 62. I will be showing you exactly how that's done. And once I have hashed this ID to base 62, so ultimately I'm gonna be getting some kind of characters at the end of the day once the hashing is done. And hence whatever I get, that will be just saved here. So suppose x1 xy, whatever I got, that will be the short URL. So I'll show you exactly how it works and all. So ultimately we'll be getting the hashing done twice, and this is how things are gonna be going on. The question comes like, how will I be generating the short URL? This is one of the ways that ultimately you can even do this thing, that you got the wrong URL, you just simply you are gonna be hashing that, and you are gonna get some kind of hash. So suppose I got my, just a minute, I have my long URL, I'm gonna be hashing that, then I'm gonna be getting some kind of characters over here. They can be actually anything, any hash, that doesn't really matter. Suppose this is the hash I got, again some kind of algorithm is actually gonna be used over here. Suppose this is what I got after hashing the long URL. And then the thing that we have to focus on, we have to only get we have to try to get as what can I say here, as less as possible, because at the end of the day, what is our main goal? We have a long URL. So ultimately what we'll be doing over here, that we have a long URL, we'll pass this long URL via a hash function, then some kind of hash will be created. So this is the suppose hash we got. but at the end of the day we cannot really give this much big hash, because at the end of the day our main goal is to just simply short the URL, and this is already big, so we are gonna be getting as less values as possible. So in that particular case, how many values do we actually need, like how many characters we need, so that we actually have how many characters we need at the end of the day. Just a minute, let me have a look at this. So this is where we calculated everything, and we actually gonna save the things, right? So ultimately 35.6, here it is. So 3.56 terabyte, not this thing actually. How many requests? This is all about storage. We don't really need to worry about the storage, rather we need to worry about what? 35.6 billion. These many requests, these many write requests we will be getting in 5 years. So ultimately what we have to keep in mind, that these many write requests, that simply means these many URLs. So we have to figure out a range in which these many URLs, ultimately short URLs, can be made. So if I have one digit, so ultimately what I said that just at the top, that we will be using the numbers, we will be using small characters, ultimately small letters, we will be using capital letters, and if I just simply calculate the sum of them, that's gonna be 62. So if we take only one character, so we can get 62 URLs. 62 URLs. If we take 2, then we are gonna be getting 62 to the power of 2, then 3, 4, 5, 6, 7, 8, it will just simply keep going on. Now let's try to get the power of 62 and see how far we go. So in that particular case, if I can use my calculator over here, so we have to take the power of, so that's interesting. So 62 power, the next one should actually be 5, not like this. In that case 62 multiplied by 62 multiplied by 62 multiplied by 62, let me see how much it is. So it is around this much. What we have to do actually, we have to make sure that we have at least this much capacity. So 35.6 billion, billion in the sense 10 to the power 9, and in 2 to the power base, that's gonna be 2 to the power 30, right? Yeah, billion 2 to the power 30. So 2 to the power 30 or 10 to the power 9. So let's keep in mind 10 to the keep 10 to the power 9 in mind. So in that particular case, divided by, I'm gonna be dividing it every time by 10 to the power 9. So 1, 2, 3, 4, 5, 6, 7, 8, 9. So how much will I be getting here? I'm gonna be getting this much. Well, this is not what we want, so we need more numbers here. So 62 multiplied by 62, so we have 1, 2, 3, 4, 5. Let me calculate this. This is this much divided by 1, 2, 3, 4, 5, 6, 7, 8, 9. I'm just simply trying to get closer to 35.6 billion or something, but again this number is nowhere close to that. So let me have 6 62s. So 1, 2, 3, 4, 5, 6. So 62 to the power 6, and how much will I be getting here? This much. And if I actually remove, if I add 10 to the power minus 9, so 1 is gone, 2, 3, 4, 5, 6, 7, 8, 9. So we are gonna be getting this much, and ultimately that's what we want. If I actually divide it by 1, 2, 3, 4, 5, 6, 7, 8, 9, so we are gonna be getting 56 point something. So 56 billion URLs can be made if we use 62 to the power 6. That simply means if we use 6 characters over here. So this is the first one, second one, third one, fourth one, fifth one, sixth one. So ultimately in this way we can get 56 point how much, 56.8, ultimately 56 billion URLs can be made, as simple as that. So once 56 billion URLs can be made, and our main goal is that to just simply have 35 billion URLs. So that's great, we have more than enough, and that's what we want. So we know what should be the number of the URL, like how many characters should be there in the URL. There should be 6 characters in the URL. But the thing is that once I got my long URL and I just simply passed it via hashing function, then I got this bigger string. Now I have to get only 6 characters from here. So 1 2 3 4 5 6. So even if I'm getting these 6 characters, there's high possibility that these 6 characters are gonna be repeated. So like as if the short URL is this that you have considered actually. So if this is the short URL that you got, but it already exists in the database, so just add some temp value in this one, then pass it to the hash function again. So this way there are ways so that you can at the end of the day generate a purely unique short URL. But this is first of all you will have to make a lot of requests to the database, so resource consuming, and plus this is not what exactly we want, because in this way it will take a lot of time to just simply even create a normal short URL. So though this is one of the ways, but this is not the best one. So what is the another way that is remaining? So there are two ways. First of all, that once you get the long URL, pass it using a hash function, pass it via hash function, you will get a long string here. Once you get long string, just take the 6 digits from there. Why 6 digits? Because 6 digits, so 62 these many characters we have to the power 6, so ultimately it is already 56 billion around. Hence we have more than enough URLs that can be made with just 6 characters, and that is why that much is enough. But the thing is that if we just take only 6 characters, there's high chance that it's gonna be repeated, and hence this is not the best way. So what can be the another way? The another way can be that once you just got the long URL, save it in the database. As soon as you saved it in the database, you are gonna be getting the ID. Once you got that particular ID, so you are gonna be just simply passing the ID via hash function. Each time the ID is gonna be separate, right? Different. ID is always gonna be unique. So first of all you will have 1, then 2, then 3. It will just keep going on and on. And ultimately ID, as the IDs are different, when you pass them via hash function, so their result is also gonna be different. So this is what that can be actually anything. Let's 1 2 3 4 5 6. That can be small, that can be big, that doesn't really matter. Suppose initially you got just this much, so 1xd, or it could be just anything. So you got this particular URL, and that is it. But as you just keep getting more and more long URLs, their IDs are gonna be generated, so 2 and 3, and those IDs are gonna be different ones, and hence you are gonna be getting different short URLs. So this way you will just simply keep getting short URLs and all, and this way the job will be done. There is only one problem, that is anybody will be able to predict, like if there are 3 documents, so the ID is 3. If there's a 4th one, so the ID will be 4 and then 5. It is incrementing it and incrementing it by 1. Hence anybody will be able to guess that. And if somebody is able to guess like what is gonna be the next URL of your URL generator, then in this way, of course you're secured. That's gonna be problematic. So what is the solution for this? The solution for this is that create a random, ultimately ID generator, or I must say unique ID generator function. So you will have to just simply create a function that is responsible for generating the IDs, so that people cannot guess the IDs that are gonna be in the database. This, if you can just simply solve this particular issue, or create a function that just simply generates the URL, generates the IDs randomly, so and randomly plus uniquely, so that's it, the job is done. And there's another thing is that you will not just have one database, rather you will have many. So there could be possibility that you have 2 databases, or you have probably 3 databases. In that case you will have to make sure that the unique generator function that you created, that that generates the IDs for all the databases, first of all this, and it knows that this particular ID has already been generated and saved in this particular database, hence it should not be creating the same ID again, because if there are 3 databases and this is the generator function, it is generating the ID for this, but the IDs are same in the databases, then that's gonna be problematic. So this particular function, it needs to be responsible for not creating the IDs ever again once that is created. So this is the thing that it actually needs to keep in mind, and again this is the job of you actually, or probably some provider that is gonna be creating this kind of function. But if you actually if you can get this much done, then that's it, the job I mean the issue has been resolved. We have unique ID generator, and if the IDs are unique, we are gonna be passing those IDs via hash function that will be generating some kind of hashes, and that is it, the job will be done. And max, how many numbers should be there? Max there should be 1 2 3 4 5 6 numbers. Why 6 numbers? Because 62 to the power 6, that is already 56 billion or something, and in 5 years we just need come on, I should be able to see that. We just need 35 or 36 billion. We just need 35 billion URLs. Ultimately we just need to create these many. So we just got this calculation done, and again you can just simply have a look at this. We just simply talked about it at noon. We even configured or just calculated everything on our own. So that's what we've done. And once this is done, then that's it. You already know what's the best way. There are many ways. The first way is that just simply hash the long URL itself. The second is hash the ID, but the problem is that IDs are being incremented one by one. Hence you are going to be creating a function so that you never know what's going to be the next ID, and they should be unique as well. Once this is done, then just simply hash the IDs. You are going to be getting the URLs. The higher the max can be 6 digit only, 6 digit in the sense 56 billion actually, and hence that much is more than enough. So already this much this thing we have already done. And is there anything that I'm missing right now? Let me see. Short URL temp value, we have already talked about this. Yeah, we didn't discuss about do we need to do this? Yes, we do need to do this. I'm gonna be talking about it, like how you convert a number into base 62 format. The way you convert a number into you base 2 format, the same way it's gonna be getting converted into base 62 format as well. So that's not really a big problem, and let me even do that. So what is actually gonna happen, that we have this ID, right, and our main goal is that we have to hash a function. Not even hashing actually, because if we actually hash this function, so it will have a lot of values. So ultimately what we have to do, we have to convert it into base 64 format. So it is in the base 10 format right now, and we have to just make sure that it is converted into base 62 format. Suppose we have a number here that's gonna be 1 2 3 4, anything, it doesn't really matter. This is the ID at the end of the day. Once this is the ID that we have, now we have to convert into base 62 format. How many characters are gonna be there in base 62? Even you can assume like this, like we have a 0 to dot, how many? We have 0 to 9 numbers here. Suppose 0 represents 0, and then if as you keep going on, 9 represents 9, and then we have what? Then we have A to Z, so ultimately A to Z, just like this. So A represents 10. You can just simply assume, most probably this is how the things go on, and Z represents 37 or something, 10 to 37 around. Let me see if I'm wrong here or right. Z represents how much? 35. 0 1 2 9, that's fine. It can be actually 36. So 11 to 36, 27 characters are there, that makes sense. And then capital A to capital Z. So if capital A is gonna be representing 37 over here, and this way it will just simply represent some number. that will actually be what, 62. So let me see, 62 minus 37, 62 minus 37, that's actually equivalent to 25, hence 26 characters are there. I was a bit confused though. So it is actually gonna be 35 over here, this is gonna be 36, and this is how what we are actually doing, that these many characters we are using in the for creating the URL, for creating the short URL, and there are total of 62 characters here, and what we are doing, that we are trying to assign those characters a specific number, so that if there is a number we can convert that number, or just simply sort of converting that number into base 64 format. Okay, so this is how the numbers are assigned. So 0 is equivalent to 0, 9 is equivalent to 9, A is equivalent to 10, Z is equivalent to 35, capital A 36, and capital Z 62. So it is like the way we have ASCII values in any language, the same way we sort of created this thing over here, kind of this reference table that we created. And now if I'm just simply writing A anywhere, that is actually equivalent to 10 in the base 10 format, as simple as that. So this is how things are gonna be going ahead. And now suppose I have this number. So first of all we have to do what? We have to convert this number in the base 64 base 62 format. So for converting that, I'm actually gonna be doing it doing something like this, the way you do with base 62, base 2, the same thing you have to do with base 62. So ultimately I have to divide it by base 62. So 1 2 3 4 1 2 3 4 divided by base 62, that is 19 point something that I got here. So once I divided it, this is the what, this much is the remainder that I got. So 19 point something is the remainder here. So coming back to this one, the remainder that I got, that is actually 19 overall. Let's keep it approximate here. So 19 is the remainder, and is 19 the remainder, or just a minute, let me use the calculator directly over here. So we have 1 2 3 4 divided by, come on, 1 2 3 4 divided by, not multiplied by, actually divided by 62. That's actually gonna be 19 point something. So 62 124, this is actually the result that we got, 19 point something. This is where it's gonna be. And what is the remainder here? Let me check that thing out as well. So how can we get the modulo here? Here it is, the mod. So that's great. So 1 2 3 4 and mod by 62. So we are getting 56. That's great, we got 56 here. Once we have 56, then we have 19. So 19 multiplied by 62, let me check even this thing as well. 19 multiplied by 62, that's gonna be around 1100 or something, that makes sense. And let me clear it. So this much is done. Now I will be dividing it again. So the now I don't even know the name of it. This is the remainder, that is for sure. This is the divisor, this is the dividend, this is something, let me even see the names of these, I forget all the time. So division, math, division, English, names, crazy way to just simply find. So yeah, so we have dividend, dividend, the number being divided. So the number which is actually being divided, that is called dividend. Divides the number you are dividing by. So ultimately over here, not this one, this one is the dividend, this one is the divisor, this one is the remainder, this one is what? In Hindi we say bhagfal, and here there is actually quotient. Okay, that's fine. In Hindi, I am quite comfortable. Okay, by the way, the quotient is gonna be 0 over here, 62 0, and the remainder is actually gonna be 19. Alrighty, so we have these two things over here. We have 19. Again, you have to go from top to from bottom to the top, probably something like this. And once you go, so you have first of all 19, and then you have 56. So the first digit is 19, and the second digit is actually, first one is 19, second one is 56. So 19 is called what? We have A 10. So we have go to 9, so A 10, 11. Okay, 10 A, B, C, D, E, F, G, H, I, J, J. 19 is J. And what is 56 here? So we have 62 as Z, Y is 61, and X is 60, X. And now, suppose, just imagine, there's gonna be some number, suppose U, I'm not even sure about this exactly which number that's gonna be, but JU, ultimately let me even see. T, U, V, W, X, Y, Z. So ultimately what I have to keep in mind, that I have 56 and 6. So T, U, V, X, Z. So before T, R, T, U, V, W, X, Y, Z. Not really R. R, T, that's gonna be U if I'm not wrong. U, V, W, X, Y, Z. Yeah, that's gonna be U. Great guess. Okay, so this is, I mean, this may not be correct, but this is the way you actually get the things done. So ultimately what you are doing, you got the ID. Once you got the ID, you are gonna be getting the you will be converting it into the base 62 format. Once that is converted, you have already assigned those numbers. The result that you are gonna be getting, that already has its own values. So at the end of the day, JU that you got, this is actually the URL. So you will have your https / suppose bit.ly/ju. This is gonna be the URL. This is gonna be one of the URLs. So this is how the things are gonna be going on. So we have gone through this thing pretty crazy, I know, but this is how the overall things are gonna be working. So ultimately, what is the benefit over here? The collision is almost impossible, because every time you will be getting the new ID. Hence, once you got the new ID, the base 62 format is gonna be different, and once the base 62 format is different, you are gonna be getting different URLs, short URLs. But that's one thing, you need a ID generator, that too unique ID generator. So that is what you have to keep in mind. As for the URL length, that is not fixed, but at the end of the day, you will not be getting a big URL, so you don't really need to worry about that. And then if you have the ID generator, then that's really great. If you don't have, then of course the IDs can be guessed. Hence you should have the ID generator, and this is how things are gonna be going on. So we need to build unique ID generator. That's the sort of the important thing, and that is it. The job is done. So what if you congratulations, we have almost gone through everything. So this is what we have to keep in mind. So ultimately, when it comes to creating a URL generator, so first of all, again, business logic, you have to just simply write that there are going to be 20 million users. Hence we have to we got the back of the envelope calculation done. We just simply calculated the things some way or the other. Once that is done, then we talked about how we can generate, and not even that, we talked about the database, which kind of database we should be using. Then we talked about the database scaling. So if you want to scale the database, so you are going to be using consistent hashing algorithm. Again, what is this? I didn't really talk about it in detail, but if you just simply search consistent hashing algorithm in Java or anything, doesn't really matter. So consistent, you will get a tons of what this is what it does. You have many nodes, it's divided, and you can just simply read more about it. I mean, this is how it just simply goes. I'm not gonna be reading. Overall, I have the idea. That's more than enough for me. In future, if I'm actually using them in my real life, then I'm gonna be knowing more about them. For now, even theory that the theory that I know, that's more than enough. Then we talked about how we are gonna be generating the short URLs. We decided to generate the short URLs using the IDs because they are gonna be unique all the time. But we'll have to be responsible for, I mean, we'll have to generate the unique IDs every time, and we have to just simply take care of this particular thing. We will convert it into base62 format, and after that it got converted into the URL as per the this table that we have, this reference that we have created. Is 0 references to 0, 9 references to 9. It just simply keeps going on, and this is how it just simply works. Okay, that's it. The job gets done over here. That's what I had to just simply talk about. Now we can of course work on creating the, what is that called, creating actually a application that creates that URL, I mean short URLs, and that is actually scalable. So all the theory is done. Now the practical stuff we will be of course doing it someday or the other. As for right now, let's switch to the another thing. What is the another thing over here? Just a minute. That another thing is, if I can see it clearly, that is Kubernetes section. So let's start talking about them. That would be better. So we have gone through this. As for this Kubernetes, yesterday we actually went through quite a lot of things. Let me just simply continue from there, and we will try our level best to at least get the deployment done, and later we will see the other things. So here it is. Especially for getting the deployment done, I need to make sure that I have the AWS cluster, and hence first of all I'm gonna be creating the cluster. Again, there are a lot of things that we have to take care of. We are gonna be going through them one by one, but as for right now we need a IAS cluster. This much configuration I'm actually gonna be using over here. So let me exit. Actually that doesn't make any difference. CD ls, and if I want to create a cluster, so EKS CTL create cluster, and file name is gonna be what? File name is gonna be EKS cluster. Let's simply run this. So ultimately a cluster is getting created on AWS. Okay, let it just simply keep working, I mean keep processing the things in the background. Meanwhile we are gonna be going through these things. So yesterday we talked about this much. The thing that we had to get done today, that is whenever we are running the backend, so before the backend even starts, backend needs to make sure that it is the backend or something else. We are gonna be starting the database, then we start the backend. Whenever the backend starts, it needs to make sure that it has to migrate the data to the database, migrate the schema to the database. That is something not getting done right now, so we are gonna be focusing on that. And yesterday the thing that we actually discovered, that is that was I forgot, job. So let's simply go through that, how this job related stuff works here. So if I come back here, just a sec, give me a moment. So when it comes to jobs, so where could I have kept them? Probably here in this one. Init containers we discussed about. I mean we just simply came to know about these things. We have this job thing, so this is how we create the schema for a job. So let me just simply run this. So what will it do? Restart policy, that is never, I don't even know what it does, but ultimately this is the command that we have. These are the URLs. It will have the database URL, and apart from this particular thing, it will have the image, and it will be responsible for migrating. I hope it will work. I don't know, this is the first time that I'm actually gonna be doing. So before even starting the backend, I have to run this. Let me paste it here and see what's gonna happen. So first of all, we have the namespace, we have the config that we have, that's great. API version batch 1, that's okay. And job is this Prisma migrate, that's fine as well. It will have a namespace, so namespace, that's gonna be, what is the namespace? Todooj app ns. Then the template spec, that's fine. Name is gonna be migrate. Your backend image. So the backend image is what? This is the backend image that we are gonna be using. Hopefully it's gonna be done. Control C, and the backend image, that's actually gonna be here. What is gonna be the command? So command is gonna be bunex, because we are using one, prisma migrate dev. Hopefully this is gonna be the one. env database URL, that's gonna be now what is the database URL? The database URL is gonna be this, but as we are using environment variables over here, so how we are gonna be getting the value? So let's see how do we get the values from configs. So if I'm using config here, let me duplicate it. It's gonna be quick. I'm just simply gonna be focusing on the important things that need to be done. So we have to just simply know how we actually pass the values in config map. So we have the config map and the values are passed like this. So we have environment variable, we have name, then value from, this is the important thing here, value from config map key, and the reference is gonna be this, but the key is gonna be the port. The same way it's gonna be done over here as well. Okay, so let's do one thing. Let me just simply copy it from here, or probably the whole thing I need to copy. So we have the environment variable, we already have the name over here, or I can say keep the things like this. Okay, that makes sense. So ultimately what we'll have here, we'll have the database URL for sure. So database URL, that's gonna be the one. Value from config map keyref, that's right. Backend config, what is the name of the config here? It is the to-do's backend config. So this is the config that we have here, control C actually, and this is the name of the config. What are we gonna be getting from there? We are gonna be getting the database URL from there as for right now. So database URL is gonna be here. Anything else that we actually have to have here? So we got the database URL, and do we need to have all allowed origins or port number? Not really. Hopefully it will be doing the job. I don't know how it will even do that. It knows the command, I mean it will be able to do that. It knows this bunex prisma migrate dev, right? So it should be able to migrate that, and this is the thing. And then over here I have to provide some environment variables. So let me copy it. Just in here we have to provide the environment variables. So just under ports, this is how we are going to be going ahead. Then we have names here, then there are values, and this is how things are. We have first of all database URL, then just in here we have to provide some more things, like another one, not this much, this whole thing. Alrighty, so this is how I'm gonna be having the data, like environment variables. And first of all, that's gonna be database URL. Second one is gonna be allowed origin. So let me paste these things over here. So key is gonna be allowed origin, the value itself is gonna be allowed origin, that's fine. And then the lastly that we have, that is port. So that's done as well. So this way I'm gonna be getting all my environment variables, they are gonna be passed over here. The job will be done. Anything else that I'm missing? Service, yeah, sort of it is done, but who knows whether it's actually gonna work or not. So the main goal is to just simply make it work somehow. Once it is working, then we'll think of something else. We'll think of auto scaling and all, but at least this much should be working, right? To do service, everything seems to be okay. So ultimately the backend is done, the database was already done, frontend is done, ingress manifest, this is done as well. Let's give it a try. What is missing right now? If I go to the backend right now and source index.ts, and over here I have course allowed origins. It is just simply getting it from the process env. Allowed origin has what? We'll have to have the URL over here for the allowed origin. Let me allow everything for now. Allowed origin is actually gonna be everything, even if I have there. For this thing I will have to build the image again. That's right, of course I will have to. I'm gonna just simply allow it. First of all, I wanna see whether it actually works or not, otherwise it's gonna be crazy if it doesn't work. By the way, if I want to start my Docker, for that thing sudo mod proc kvmnd. Alrighty, this is done. Now I should be able to start that. So Docker desktop is start. So desktop is gonna be started right now. Once desktop has started, after that Docker images, these are the images. By the way, I have to go to the front end section, not the front end, rather the back end section right now, ls, and we have to build the image again. Docker images, the backend image we have to build. So Docker build tag is actually gonna be the same, at least this time, and in the current directory it should be just simply getting it done very soon. And once this is done, hopefully we will not get the errors and all. Once this is actually done, then let's see what's gonna happen. We should be able to run multiple pods in a node. Multiple pods can run in a node, right? Yes, multiple pods can typically run on a single node in Kubernetes cluster. The fact is that our terminals, okay, the ports can actually run. Kubernetes default to 110, but can be configured to 256 per node. So per node we can run these many nodes. Okay, let's not worry about this. Let me see if that is running. It is still just simply creating the image. That's okay, fine. We even have to push the images, so we have to keep this particular thing in mind, and that pushing does take time. Alrighty, so Docker images, now Docker push. I'm gonna be pushing this image. Hopefully it will not take a lot of time. It will take around this much time, and I hope meanwhile it's quite fast. That's good. It's gonna be taking a while. So these images need to be pushed. So this is the first thing. The another image that I have to push, that is the Docker images. The backend is being pushed right now. I have to push even the front end one. So this is the front end image. Control C. Docker push this front end image. Let's push this one as well. So both the images are gonna be pushed. And once this particular thing is done, that's it. Then we have to just simply start working on the deployment section. Overall, the configuration is ready as well. Now just fixing the bugs. That's the only thing that is remaining. So let's see how it's gonna be going on. So let it just simply get done. I'll be back within a minute, and let the process be let it be processed as well. I'll be back. Alright everybody, here we are, and the first one is almost, that is done actually. The second one is just remaining. 224, that's too much, but okay, never mind. So the first thing is done. Let's simply clear it, and that has been just simply deployed. That simply means if I go to, pushed ultimately docker.docker.com, I should be getting it here. Sign in. What was the ID? Email ultimately. Okay, we are already in. So this is the backend one that got just uploaded right now, and to-do's backend, and we should be getting the to-do's front end as well very soon. Once this much is done, then we are just simply gonna be working on the deployment part. Great. Even this Kubernetes is not ready yet, so we have to just make sure that this is gonna be ready. So by the time it is ready, I will just simply deploy it. Again, there are gonna be bugs or something or the other. Overall, what we are trying to do, let's simply try to draw the flow exactly how it's gonna be working. So control plane is being managed by AWS only. We will only have the nodes. Suppose this is the first node that we have here. So this is one of the nodes. Similarly, this is another node, and we can have actually many nodes here, and but there can be many pods running in those nodes. So suppose we have only 2 nodes here running, because in our case we actually have 2 nodes running. That is why I'm not creating many here. So this is how we have. Now in these nodes there can be multiple pods. So there can be 1 pod, there can be actually many pods running in these nodes. So they are nothing but pods here, just like this. So let's see how many pods we actually need here, but ultimately many pods can run in one node. So this is how we are gonna be going here. There are many pods ultimately. This is nothing but a node that we have here. So node number 1, this is gonna be node number 2. So we have different nodes, we have different pods. The first one is gonna be front-end pod, of course. The another one is gonna be backend, and there are gonna be 2 backends actually. That's actually gonna be insane. So there's gonna be a service that will be redirecting. So it's gonna be like this. This is the backend. There are gonna be 2 backends first of all. In our case, there are 2 backends, just like this. 2 backends are gonna be there, just beside each other. Of course, these are nothing but pods. Let me even make them change the color of the pods to blue. That would be better. So this is the first one. This is the second one. They are the pods. So 2 backend pods are gonna be running, and there's gonna be service here. So we have created cluster IP. So cluster IP service that is created, it will give us the IP address for it. So ultimately, this cluster IP is gonna be connected to both. So and it will just simply be giving us the IP addresses of these backends. IP address in the sense the host name ultimately, and we are using this. We will be able to talk to them. Similarly, I have my front end, and this front end will have its own. I have my front end here. Front end will have its own IP address, ultimately cluster IP. Front end does not have its, front end will have its own cluster IP, so it will also have the same. Not the same, but it will have its own cluster IP, and that IP in the sense sort of you will have the IP address of this particular front end running, pod running. So this particular thing is done. So you have your backends running. Similarly, we will have our database running, so DB running, and DB itself, it is also gonna be a pod. I mean, this is how the things are going. And DB will also have its cluster IP. So this is how it's gonna be going on. So for now, at least I don't have any. And similarly, you will have one more here. I mean, that can be here, that can be here. It doesn't really matter. They are just simply nodes, and the pods can actually be running anywhere. Suppose we have one more that's gonna be ingress controller that we have created manually. So this is gonna be the ingress controller. And this is again gonna be a pod we have created manually. We are using Nginx inside this, and it will have its it will have a load balancer IP. So it will have load balancer ultimately. So it will have a load balancer over here. This load balancer will be giving me the DNS. So we will get a load balancer DNS, and using this we will be able to just simply make a request to this, and once the request goes here, as these are the nodes and these are the pods, these pods have their IPs. So as you can easily make a request from one node to the other, and you already know the IP address of the pods, hence you are gonna be able to make a request from this ingress controller to the request can first of all the request will go to the front end from this ingress controller. So this will actually go on like this. Then the front end will be, because again I will just simply be exposing front end, and then front end will be making the request to the back end, and not just the back end, actually the request doesn't go to the front end, rather the request goes to the service, the service that we have created. So the request goes to the cluster IP forwards the request to the front end, then front end sends the request to the backend's cluster IP. It will be load balancing the request over here if I'm not wrong, and then from the backend we are gonna be making a request to the IP of the database. So this is how things are gonna be going on, and the request can actually go from both let me make it like this, that's gonna be a bit better. Yeah, so the request will be going to the database cluster IP, it will be getting the data from here, it will be just simply processing that, they simply will return to the front end. Front end will be you will get front end will send the data back to the ingress controller, and the ingress controller will be forwarding it back, something like this. I mean, this is what I think should ideally happen, but let's see what's gonna happen. Okay, so this is what we have created, the whole structure that is gonna be inside a cluster. So ultimately this whole gray color is nothing but a cluster here. As for the control plane, that is actually being managed that will be managed by AWS, so we don't really need to worry about that. This has been created, so we've done with both the things. Now what am I gonna do here? This is the cluster, so let me see. Get nodes. As mentioned earlier, we only have 2 nodes here, that is why I just simply created 2 nodes here as well. And what am I gonna do now? Interesting. Get pods. Alrighty, let's get going. So cd, what do I need to do first? That's interesting. Doing something for the first time. Not first time. What should I do first? Let's first of all create the database, that would be better, right? cd db ls. We have manifest over here, let me go one directly back at least. Now that's fine. So cd db / manifest, not this, yeah, sorry. How do we apply this? Apply, file name is gonna be not backend, db / manifest.ml. Now let's have a look at the file of the database configuration. So this is the namespace, backend to do replica, that's gonna be only one database as for right now, and password is gonna be this. Okay, that's fine, and it should be sort of created. Let's see, run this. Wait for a while, database has been created, namespace has been created, service has been created. So get svc service. Again, you will not be getting, you will have to specify the namespace, and that's gonna be to do app ns. And right now this is the service, db service. This is the cluster IP, 10.100.145.181. It is actually running on 5432 port, that's fine, and this is how just simply getting done. We have the service over here. Apart from the service, get pods, and that's gonna be to do app ns namespace. So we have this pod running. This is actually running in the running state. That simply means the database is running. Lovely. As the database is running, let me SSH into the database. Execute in the interactive mode. Not SSH into the database. Let me go inside that actually. Yeah, we'll have to use the namespace here as well. Namespace is gonna be to do app Japanese. That should be fine. Let me exit from here as well. It is simply saying that pod not found. That's interesting. Why? This is the pod. Namespace is gonna be to do app namespace. Yeah, we are inside that particular container that is running. That container is actually running our database actually. Okay, that's fine. If I run psql here, what will happen? Connection error. Okay, psql. What is the command usually? Username is gonna be postgres. Port is gonna be 5432. Host is gonna be localhost. Literally localhost. Yeah, here we are. Now the database is running, but how can I check the things? Forward slash. I forgotten the commands actually. I'm not even able to type anything here. It's stuck. Okay, now I'm able to. Forward slash dt. I think this is the command. Did not find any tables. Ultimately, yeah, database is working fine. Congratulations. And exit from here. So we have our database up and running. Interesting. So the database is running. Great job. And one more thing we can check. K describe, again K stands for kubectl over here, so don't get confused. So even if I write this kubectl and describe the name of the pod, describe pod in this, of course I need to use the namespace to do app s. So I will be knowing more about my database, and it has this particular label. Apart from this particular thing, it has been created in the 176 node. Let me see. K get nodes. So 176, it has been created in the second one. Nothing is running in the first one. That's great. What is the next thing? Database is created. Let's simply create the backend. That's gonna be interesting now. Okay. ls k apply f backend manifest.ml. Yeah. Okay, that's a problem. First of all, unchained to-dos backend config got created, Prisma migrate got created, it even migrated the deployment created, error creating backend manifest service in version 1 cannot be handled as a service JSON, blah 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 blah. Service version 1. What is the version of the service here? One. What did I have here? One API version. What is the problem? If I just simply copied and pasted the service, so that should not really be a problematic thing. What does this mean? K get pods to do app s. Huh? This is problematic. So Prisma migrate, this failed. Why did it fail? Okay, describe. I don't even know how to use this Prisma migrate. I'm doing it for the first time, so even if it is failing, I have to take the help of AI here. To do app namespace, but let me see if I can get something. So it is saying that created, started, everything went well. So what was the problem? Okay, let me give it to the ChatGPT and ask for the suggestions first of all, because I have no idea, especially with the job thing, how job actually works in not this ChatGPT. Yeah, are you crazy? Is this right? You are very close, but there are two important mistakes. First of all, this is perfect. namespace config में mostly correct database URL. This is correct if you really just confirm service list. Okay, that's fine. Prisma big issue. Dev problem. Dev is for local development, not production. So Bunix Prisma deploy we have to use over here. Okay, that's fine. So that's gonna be everything looks good. Replicas this service wrong selector in yaar. Am I crazy? There should be Kudu's backend. Wow, that's the mistake that I made here. So in the service, am I really making this mistake? Getting the notification. Yeah, such crazy thing this is. First of all, this is gonna be like this. The another thing is that the mistake that I actually made, there should be deploy over here. So let me have this deploy here. And apart from this particular thing, I have to go through it well. First one is correct, that's fine. Second one is config map mostly correct, that is also right. Problem big issue, we have resolved this. Deployment good replica, this service is gonna be, that's we fixed this. Service port confusion, port 3000, this means inside the cluster service runs on port 3000, that's right. Container, this is okay but confusing, so it can be 4000, that's fine. Okay, never mind. Course allowed origin localhost. In Kubernetes frontend is not localhost, so fix depends on your frontend. If using service, use service DNS. So that's actually gonna be this particular one. Lovely. Arey bhai, frontend DNS. This is gonna be the allowed origin. That makes sense. I'll do it, but I am allowing all of them right now. This is how it's gonna be going on. Okay, interesting. So as for allowed origin, first of all, yeah, I have to correct this anyway. So HTTP, what should be the URL anyway? ChatGPT, where are you? I need to take the help. First of all, this is gonna be the just overall colon, and then front end. First of all, I need to have the service name. What is the service name? Uduj front end service. Then Uduj app ns. This is the, what is this? This is the namespace dot svc dot cluster, I mean the dot local. That should be it. Front end service again to do front end service, that's the name I mentioned on my case, and in my case actually, and this is done. Great job. Port is gonna be 4000, and overall things are fine. So let me do one thing. The deployment is created. Okay, get deployment Kudu's app ns. Let me get rid of this deployment. So okay, delete deployment, and this is the deployment Kudu's app namespace. Okay, that simply means now I should not be getting that. Okay, now ls I have to apply it again. So okay, apply f backend manifest. Here we are. Am I gonna be getting more errors right now? The job Prisma migrate is invalid. I'll have to give it to the AI, honestly. Don't blame me for that. I think I can figure it out. Field is immutable. What can I figure out? I am not even getting what's written here. Let me have a look at the job first of all before even taking the help of AI. This is the job, API version, metadata, Prisma migrate, namespace is gonna be this, template is gonna be this, name is gonna be migrate, unstoppable the coder, to do's backend latest, that's fine, Bunix Prisma migrate deploy, database URL is gonna be this, value from this, to do's backend config, database URL, blah blah blah. Overall things are fine. So then first of all, let me give this to the AI and see if there are any issues with this, or overall things are fine. Okay, it is 80 to 85% correct. Okay, This is not correct for browsers. So why DNS SVC local works inside Kubernetes only in browser? Right? This is not correct for. This works inside the local host. That's right. So correct approach can be what? Local development. This is gonna be this production recommended ingress or domain. You need to have your domain URL. Okay, I mean, let me keep it like this. You need to have your DNS. I mean, yeah, I mean that's to do. That's a to do. And for now, we can have this your domain name. I mean, this can be an example here. This can be an example. Makes sense. Okay. And when I have my DNS, it can be HTTPS. It can be both actually. So let this HTTPS be here. That's gonna be the. Okay, that's fine. This is done. Port. Now the question is, if everything is actually right, what does this either mean? Oh, I was about to fall. That's a classic event. It is job Prisma migrate is invalid spec is immutable translation. You already created this job once, and now you are trying to change the export given it is not allowed. Why this happens? Okay, got it. First of all, we have to delete a job. Amazing, lovely. That's insane. Okay, get deployment backslash /s. So I have this. I have to delete this. So for deleting this, okay, delete. I didn't delete that job the last time. That was the problem. Deployment and paste namespace is gonna be tools app ns. Okay, get job tools app namespace. This is k delete job. This is the job that I have. Namespace tools app ns. Okay, try to get that again. We don't have any job. Now try to apply. Yeah, k apply f whatever. Congratulations, it worked. So k get a job for all. So this is the job that we have. K get pods for all. I mean, let me get the pods for and to rouge app namespace. Congratulations, we have the errors again. Hi. Why are we facing these errors here? Okay, get logs of this to do Japanese. Will I get something? There should be log. Hey? Come on, K just logs. I mean, I'm not sure whether this is the right command or not. Yeah, this is the right command. So loaded a Prisma. This could not reach app Prisma schema provided by और वाह क्या बात है. It is simply saying that in my data in my backend image there is no this Prisma conf.ts. Okay, let me see. ls. How can I check it? I have these pods running, right? Let me k execute interactive mode this sh namespace is gonna be to do app ns ls. Wow, we have node modules, we have package JSON, we have Prisma, we have source. Insane. We do not have this Prisma here. Exit. The image was wrong, bro. I mean, the image that we created, that's not the right one. It doesn't have this backend image doesn't have Prisma in it. I mean, this whole folder, it doesn't have. And what is the Docker file? Okay, so app Prisma la. What I did, I commented this. I don't need this is required right now because I do need to migrate the database data to the database this time. So cd docker build. This is gonna be the version 1 this time, or should I keep it the latest? Let's keep it version 1. Yeah, let's keep it version 1. Okay, keeping version 1 or not, it's completely up to you. I have made some changes, so I'm gonna be keeping it version 1 so that I can push it. Okay, docker push this version 1. Alright, it's gonna be pushed very soon. Okay, this is already done. And once this is done, then I'm gonna be back here actually. Backend. This is gonna be version 1, and let's create a deployment. For all. So we have to do backend here. Now what I'm gonna do, okay, apply f cd to this, oops, okay, apply f backend. I already have the job. Won't that be problematic? That will be problematic. Let me delete this, start afresh. I mean, yeah, I don't have jobs separately, so I do need to do it like this anyway. So what am I gonna do? I could have just directly applied this, and the deployment will have been done the right way, but even job has the wrong version here. It should be version 1. That's the problem, so I'll have to reapply the whole thing. Before that, let me delete it. So okay, apply delete. Namespace root app ns la. That's fine. Okay, that's done. Okay, apply f man backend manifest.ml. Nah, not yet. I have to delete the job. Okay, get job. Okay, delete job. Prisma migrate to do Japanese. Alrighty, time to apply that. Alrighty, here we are. Okay, get pods to ns. Let's wait. Wow, everything is running. Your database is running, your two backends are running, your job is running. That is in the running state. That simply means it actually applied everything. It did, didn't it? Let me see. Okay, execute in the interactive mode. This is the database. Namespace is gonna be app ns sh ls psql user, that's gonna be Postgres of course, and psql command so yeah, this is how we are gonna be going ahead. So host is gonna be localhost, and database is gonna be todos. Now what is the database name, yaar? Database. What is the name of the database? Database URL todosdb. Yeah, that's right, todosdb. Wow, amazing, that is created. I never expected this much to happen. We have our to-do schema over here. Lovely. We did it actually. We created a backend inside the cluster. So actually this is what happened. If this much is done, then okay, I can do everything else. Other things are easy. So no need to worry about that. So what we are doing actually, we have the DB, and when I started my backends, so before even starting them, I ran a job. So a job ran ultimately. So sort of, let me have this thing over here. I just simply ran a job. That job was responsible for migrating the data to the database. So we will be just simply migrating the data here, of course, but this job just got that particular thing done, and that's it. We have the data here. Wow, interesting. What time is it? 10:30. Crazy, yeah. The time even flies. I'll anyhow have to get this thing done, so let me get it done really quickly. Remaining things even better, we'll be digging deeper into it. We have to even scale it better and all. We have to do a lot of things, but as for today, let's simply exit, at least get the deployment done, this particular part done really quickly. So we have done this much. DB done, backend done. Let me apply F frontend manifest, but let me see if there's something wrong or not. So namespace deployment, this replica match label, template metadata. Okay, this is the init controller that we have, and it is doing the same thing. I need to remove it from here anyway. This is inside. Wow, this is inside. By mistake I kept it inside front, and that's crazy. Okay, let me remove it anyway. Thank God I just even reviewed this. Otherwise things would have been crazy. Template, containers, front-end, to-do front-end, toggle, this fine. Service, match level, remove it. Don't know for what reason I kept it here. TCP 3000, did this. Let me apply it. Spec. Something is missing. Spec replica one selector match labels. This template labels to use front end containers. This is wrong. I'm missing many things. Just a minute, give me a moment. We need to have a spec here, right? That I don't have here. So if I go to the front end, cut it from here, have a spec here, paste it here, and this much should be fine. Okay, get deploy mens for all. Just a sec, I have my metric server running. Metric server, okay, forget about this. These two things are running right now. Let me run that again. Congratulations. The namespace front-end service, that is unchanged though, that was already created, and to-do's deployment that got created right now. So okay, get pods to-do's app ns. So we don't have yet. Prisma migrate, that is just simply saying that it got completed, so that is done. Great job, by the way. We have to just wait for a while. Okay, so right now front end is also running, so that's what we wanted. So front end is running now. What is the next thing? ls, we have to start running ingress, right? Let's see whether there are mistakes in ingress or not. So this is the overall proxy that we have, and deployment, ingress, templates, inspect container, nginx, volume mounts, mounting the volume, service it has selector, protocol, ATP. That's fine, great. So ls k apply f ingress. This is the manual controller that I have created using nginx and manifest. Here you go, done. Okay, get pods and so error, why? Crash loop back off. It is using nginx. What is the problem with this? Nginx latest, nginx ingress, the image of the nginx. What is the problem, bro? Interesting. Okay, describe pod namespace to do Japanese. Okay, so successfully pulled the image, created the container successfully. This started back off, restarting failed. Okay, what does it mean? Usually we do this much only. I'm missing something here. Let me have a look in my notes quickly. So whenever I'm creating the controller ingress, not this. This is about the controller. I'm talking about the manual ingress. Reverse proxy that I created here. No, yeah, it is right. I mean, how can it be even wrong when it has just simply created everything? What does it mean? Let me see. Take the help of AI really quickly. I don't have a lot of time here. What does it mean? So the let me see what I can do here. That simply means something is wrong here in this particular section, but what can that be? Let me give it to the chat GPT, the whole configuration. To do front end service. Namespace was this. Come on yaar, am I crazy? Why did I even mention them? Last time what I was trying to do, I was thinking of creating the namespaces, different namespaces, then I thought of creating only one. So to do jab namespace, even I'm using the right one here. Let me see, yeah, what can I do here? ls k get deployments for all. So that's gonna be the ingress one, right? So k delete, as I have made some changes so I can directly apply it. So k apply f ingress manifest. It's actually gonna be configured. Okay, get ports to fs same issue. Let me see what I can do here. Namespace is gonna be this, that's fine. Nginx. So to do front end code in the code.site, from here I will be just simply sending the request http. That's gonna be to do front end service, okay. To do app namespace, this is gonna be the namespace. Namespace for all, that's fine. svc cluster local 3000, and then to do backend service, to do app namespace svc cluster local 3000. They are using the same namespace, but they have the different services, though they will have different IP addresses. That's fine. Okay, interesting. Labels, Nginx port. Let me give it to this chat GPT and see what it says. This is almost perfect. Okay, that's great. Most likely rename issues. Nginx resolve this. I resolve inside HTTP. Even that's just all about making it better, but overall things should be working fine. Oh, it is actually in the running state. The previous one got deleted and the new one is in the running state. Great. So get svc namespace to do app ns. So I actually got this DNS over here. As I got this particular DNS, so now what I have to do, if I just directly make a request to this one, then what will happen? This will not directly work, or will it? The first one is gonna run. That simply means front end. Wow, congratulations. Why it is working? Because if it doesn't match anything, because in here in the configuration it is not matching this proxy pass, it is not even matching this, so it just simply shows the first one, and the first one is the front end. That is why I'm just simply getting the result. Now the question is, it is just simply saying that http localhost 4000 to originate. Where is this http localhost 4000 is coming from? From the front end side. I'm not passing the what the hell? I'm not passing the environment variable here on the front end side. It's gonna be crazy when it comes to the front end one here. we have the front end here, but at the end of the day no environment variables are being passed, and over here we did pass or didn't we, backend, front end, environment variable, we have this particular backend URL, but this is not gonna be the one right now, so we need to have it. So let's have it as a to do here. That's enough for now. I actually have to, it's already 50 around. It is definitely gonna be done. What I have to do next, that is inside front end, the to do's. Create secret that holds next what, or even creating this is not a big deal. Let me create the secret really quickly, as I'm doing it here, so why not get it done. So when it comes to secret, it will not take a lot of time, hence I'm getting it done right here. Secret config map secret. This is the overall, come on yaar, let me just simply copy it directly. So this is the overall configuration for the secret, and we can have all the environment variables of .env, but as I have only one, so let me do one thing. What am I gonna have here? That's gonna be next public backend URL, right? This is what I'm gonna have, but that backend URL is gonna change. Now I will have to create a DNS. I have to go to hosting and I have to, create the subdomains and all. So ultimately it's gonna be a lot. That is why I will be getting it done tomorrow. But the basic things I'm getting them done right here. So almost everything will be ready, except one thing. Or should I get it done right now only, so that I'm free tomorrow? That could be the case as well. Hopefully it's not. It will take max half an hour. So let's get it done too. So front end, paste it over here, and the value of this is going to be colon, and what are we gonna be having next public URL? What is gonna be the URL of the data? Front end will be making the request to the backend. So what is gonna happen here? That this is the front end that I have, and this front end will be making the request to the backend. So do I need to use the domain name over here, or the internal domain name? Which one should be used? So front end will be making the request to the backend. So how about making the request to the cluster IP? It will be done directly in the sense, even if I have this thing, first of all I have to convert it into base 64, but for now what am I gonna do? Even if I have like this http colon this, then to do backend service dot to do app namespace dot svc dot cluster dot local. Even if I have this colon 4000, it should be working. Now of course I have to convert it into base 64. So coming back to this one, so I have this http okay hटाओ http colon to do backend service, that's the name of the service of the backend. I hope that's the one. Backend. What is the name of the service? Backend. To do backend service, right? This is the name of the service of the backend. Coming back to this one, then this is the namespace svc cluster local 4000. So let me go to the database. This SBC cluster local. Okay, that's fine, right? So this much we have done. Let me just simply decode this. What? Encode it, yeah. HTTP colon this dot todoge app ns dot svc dot cluster dot local colon 4000. I think that's where my backend is running right now. Backend where that runs environment variable 4000 on the front end side. Environment variable localhost 4000. I have to just simply replace this. So that's replaced with local todoge backend service todoge app ns svc cluster dot local. That's done. I have to encode it. This is what I got here. So let me copy it. Once copied, backend not front end. Let me paste it here. This is how it's gonna be going on. Already seems to be sort of done. Even if I encode it many times, the result is gonna be the same all the time. I can even just simply copy to the clipboard like this and replace this whole thing. This particular thing seems to be done. So we have our secret over here. Once we have the secret, the question is how are we gonna be using the secret? So they are gonna be used like this. In the environment variable, I will have the secret value from config map, not really this one. We are talking about the secret. So value from secret keyref, this is gonna be the one. Let me copy it. And volume mounts, we are not really using them. So we have the deployment, we have the front end over here, and just somewhere here actually I'm gonna be pasting everything. Let me structure it better. Not really, this is not how it's gonna be done. So let me cut it. I have environment variable here. Just below that I have it like this, and that is the job is done. Now what am I gonna be getting from there? That is gonna be next public backend URL. That's gonna be this. That's gonna be this. What is the name of the config? That's gonna be the secret. Todoge front end secret. And now mainly should be used for backend, but okay, never mind. Todoge front end secret. That's the name of the secret that I have. Next public. I know this is mainly you store confidential things in the secret, but okay, this is just for the learning purpose. Usually you should use it for the backend, but okay, never mind. And you should use config map for the backend and front end, but okay, never mind. I've said it many times, so never mind. To do the namespace secret key name next public backend URL, and that is it. The job is done. So what am I gonna do? Okay, apply F front end manifest. Backend in namespace is the problem. One more time. Already this thing is done. Okay, get pods todoge app namespace. So my front end, this is the one. It is started 36 or 38 seconds ago. That simply means this is the current one. And so if I come back here, this should ideally be working. Reload the page. Localhost to todoge. It is still getting localhost over here. Why? I'm not logging the values on my front end side, right? That should I should be doing. So on the front end side, phase.tsx, clg process.env dot, I'm actually going to log the value of it. Already this thing is done. I'm logging the value, but the thing is that I have to build the image again, then I'll have to change the version, I'll have to apply it again. Let's do it anyway. cd frontend ls docker images docker build tag name v1 Today I'll get it done. I mean, it's not like it will be done completely. I have to just simply work on the auto scaling part and all, but at least it's gonna be deployed. What else? Meanwhile, let me do one thing, because this hosting takes time as well. Now this hosting is gonna take a lot of time, but at least it takes a lot of time. That's problematic thing, but can't really do anything. Hope it works. It is already 11. Let's not work on this thing today. Hosting in that case will take a lot of time. That's the problem. I mean, it takes a lot of time to just simply get the DNS stuff ready. So even if you have set up the DNS domain name, it will still take some time to be just simply workable. So that's the main problem. What is the issue? Why is it taking this much time? Okay, fine. Next public backend URL. Makes sense. It takes a lot of time, mainly the front end part. This is the last thing that I'm doing. If it works, that's great. If it doesn't work, I'm gonna be working on it tomorrow. Whew. It's not hard actually, but it is time taking. You have to just simply fix the bugs. Hopefully work, yaar. Why are you taking this much time? Do you really think I have this much time? हो जा सो जाऊँगा मैं. Okay, fine, thank you. Docker push version 1. Let it be pushed. No. My mobile is not charged. What is the battery? 10% charge. Okay, never mind. La, this much. Why is it taking it? Probably the way I'm building my image, that's not the most optimal way. That is why it took a lot of time. So let me have a look at the Docker file. So what am I doing? If I'm building the image again, I'm just simply copying everything. Installing I just changed what? I changed the file. Okay, that makes sense. It is still gonna take a lot of, like, not a lot of time, but some time. So let's wait. Pushing thing takes time. I could have what the hell? I could have made the changes directly in the image in the Docker itself. I could have done that. Yeah, that is also possible. Instead of building it, pushing it, make the changes directly if needed. That's quite tricky, but okay. You will have to install Vim for that then. You will have to change the files anyway. Almost done, almost done. Dhanyavad. Well, what dhanyavad? It is this much remaining right now. God, just get done once. I will never ever, and not never ever. I'll not try to do it again today at least. Just let me see if it works or not. Thank you for the speed. Is it gonna take time still? Yeah, done. Thank you. So what is the next thing? CD. Let's go to the oops part again. And what is the next thing? Okay, apply file front-end / manifest. That's gonna be the, let me change the version here. That's gonna be the version 1, and everything else is fine. Here we are back. Okay, good. Pods. Do not ask me to just simply say that thing again and again. Okay, so container is getting created. The previous one will be stopped and the new one is gonna be created. Let's wait for a while. Is still getting created. The new one should be created, the previous one should be stopped. Okay, so the previous one got stopped and the new one we have here. So now if I go to close this, reload the page, we are getting this HTTP localhost 4000 to Y. This is the URL that we are getting inside the Next.js app. We should not be getting this. Rather, we should be getting. Why do we have it? Am I passing the environment variable too? Just let me have a look at this. Docker k execute in the interactive mode. Probably the environment variable itself is being passed, if I'm not wrong. That's high chance for it as well. To-dos app ns and sh lsa. Array bhai, lsa. I don't have environment variable here. When I built this, probably it got used. Probably. Probably one thing I need to do. The environment variable is not getting passed anyway here directly. cd.next ls. Yeah, we do not really have that, but I think when I built it, it used that by default. To check that, now if I do the same thing again, it will take a lot of time. That's what I don't want, because here I am directly getting 4000. That simply means some way or the other it is being passed in the image. That simply means it could be done when I am building this docker file, package install, get everything. Okay, only this thing is how is the environment variable being passed when I'm not passing it? Here we are. Just I don't know whether it's gonna work or not. Just trying something new here. Docker, what next? Docker build. This is gonna be the version 2. Congratulations. Front end version 2. Hopefully it will not take a lot of time. It will be quick this time because I haven't changed quite many things. I hope so, and I should hope so. And I hoped right. Yeah, it's not gonna take a lot of time. The only thing is that how is the environment variable getting passed directly to the front end? That's something not just digestible. Let's see. Okay, Docker push version 2. It will not be taking a lot of time. I know it. Yeah, I was wrong. Sorry. But the internet speed is fast. It will take max to max 1 minute. It's troublesome. Okay, hope it's gonna be done. This time what I have done, that I have pasted this particular URL. So if it is actually building it while just simply creating the image and just simply saving it inside .next folder, so it should be just doing the same for this one as well, and then I will be able to figure it out. Otherwise I'll have to dig deeper into it. I'll have to take the help of AI. Why fear when AI is here? I mean, right, makes sense. I have a lot of things to do, but this thing is not getting done. Here we are. It's been quite fast, actually really fast, more than I expected it to be. Okay, this thing is done. One last thing, this is the last thing that I'm gonna try. That's it, nothing else. Then remaining things are gonna be done tomorrow. Version 2 cd okay, apply f backend not frontend slash manifest, done, and okay, get pods to app ns namespace. Here we are, new container is getting created. Wait for a while. Sorry, not this one, this one. Okay, that's in the running state. Welcome back. Reload it. Here we go. We are getting it. That simply means this is actually being built at the build time. Go to the gym. It turns out, yeah, that's fine. Okay, HTTP to do the backend service. Yeah, it is obvious. The direct request is going to the, what is the problem right here? The problem is that if when I use this particular URL, first of all, I should not be using this URL directly. Yeah, I should not be using this URL directly. What am I doing here? I'm directly making my front end talk to the backend here. But the thing is that when I'm actually using this ingress, because this one is sending the request to the front end as well as the backend. So now when I'm actually using this here, come on, what? The URL was to do backend service to do this. So ultimately from the front end side, this was the URL where I sent the request. And when this went, it did not match. So it is working. Congratulations for that. The next thing is that I actually have to create a proper DNS for the front end, proper DNS for the back end, and I'm gonna be using that DNS, and this way it's gonna be resolved. Because if I'm using this, so from the front end side the request actually goes to this. This is really insane. I actually have to use proper DNS here, and then it is gonna be working. That thing will be done tomorrow. So ultimately, what is the next thing? The last thing, actually create a DNS, go to the hosting, or create front end DNS, back end DNS, and that's it. Use the DNS instead of using this. And the another thing is that this is gonna be a to do. Check if this URL is also getting built when creating Docker image. Alrighty, this is the thing that we will be just simply checking tomorrow. And the other to do is that create domain name service DNS for front end and back end, and use backend's DNS here. So let's see how it's gonna be going on. Figure out if you can get it working like this, the way it is right now. These are the to-dos, by the way, for tomorrow. So we are gonna be getting everything done. As for right now, one simple command, it will just simply remove everything. What is that? Get nodes. These are the nodes that I have, right? So EKS, CTL, delete, cluster. What is the name of the cluster? EKS, CTL, EKS cluster. Here we go. The cluster is gonna be deleted. Everything is deleted. Congratulations. There's nothing remaining. The commands, the configuration that is written, that they are right, they are working. Few things are remaining. We'll be getting them. The deployment will be done. Then we will be focusing on auto scaling. I mean, scaling up, scaling down. All those things are gonna be happening. As for right now, nothing. Bye bye. Take care and see you. That was it. I'm gonna be catching up soon.